Bismillahirrahmanirrahim. Assalamu alaikum everyone. Today we're going to learn lesson 8 part 2, and this one's interesting. So basically you guys have learned how to add and subtract and multiply polynomials, right? So you guys have learned all of these things. And then what I was doing in that previous lecture, this is actually what happened, is intended to teach you to divide as well. But what happened is I realized the lecture was taking very long, so I detracted a certain part of it. And what you see on this right side over here was the lecture that I had done for it. So inshallah, I will be including that segment, so it'll feel awkward like I just randomly start talking, but I will include that segment so that way I don't have to do number 62 all over again, okay? But here's what we're going to be doing. We're going to try a handful of questions beyond 62 just to start getting used to dividing polynomials. And one of the questions that I'd like to try with you here is number 58, okay? So number 58, it says you're going to be taking 3x cubed minus x squared plus x minus 2, and you're going to be dividing it by x plus 2. So here's how that question really looks like when you write it out. Bismillah. So that's number 58. And so you have an x plus 2 as your divisor, and then on the inside is called the dividend. So 3x cubed, Bismillah, minus x squared plus x minus 2, right? So let's go ahead and get started with this. The first step that you do in dividing polynomials is you basically take the x that you see out here, you take this x out here, and you divide it into 3x cubed, all right? And so think of it like long division as far as how you used to go about it before is concerned. So I'll just run you through something that I will be talking about anyway, but when you think about how many times does 3 go into 47, you would really start off by saying how many times does 3 go into 4? And 3 goes into 4 once, right? So we'll stop right there, and we'll come back and we'll say how many times does 3x cubed get divided by the x? I know it's a really awkward question, but 3x cubed divided by x, what does that give us? And so what that gives us is 3x squared. And so once you get the 3x squared, you go to the question and you write in 3x squared, and that's called the quotient, by the way. So after you do that, the next step is for you to multiply. And if you're wondering, why do you multiply all of a sudden? Well, let's go back to our basic example right over here. Once you had asked yourself how many times 3 go into 4, which is once, then you would have said 3 times 1 is 3, right? And so instead of keep on scrolling over to this side, let's just take this piece, and inshallah we'll just bring it over, and then we can talk about it more in detail as it's over here. Okay, so just give me 1 second. I'm struggling with this right now. Let me cut this, and I'll put it in this spot. So that way we can keep talking about how did we used to do long division, because essentially the long division of polynomials is very similar to the long division of numbers that you've learned in, like, perhaps 5th, 6th grade, right? So like I said, what I was saying is, then you ask yourself, what's 3 times 1? And 3 times 1 is 3. So what does that mean for polynomials? Basically in polynomials what that means is you're going to take the x plus 2 and you're multiplying it to the 3x squared. All right, so you're taking basically everything that is right here and multiplying it to 3x squared. That's the idea. So when you do that, x times 3x squared is actually 3x cubed, like that. And then 2 times 3x squared is 6x squared, so plus 6x squared, right? But before we do anything, let's go back to our basic example. Have you ever asked yourself, why did you used to subtract the 4 and the 3, right? I don't know if your teacher ever talked to you about that. Like, we always used to subtract that 3. Like, I would understand 3 times 1 is 3, so you put the 3 under the 4, but why did you do 4 minus 3, right? So that kind of sheds some light on what we're doing now. Is although it says 3x cubed plus 6x squared, what you really do, what's really going on is you're putting a negative sign in front of 3x cubed plus 6x squared, and based on the previous lesson, you can tell that, well, that actually is going to lead to this situation. So instead of erasing everything on that second row, what we generally do is we put a negative, right? We put the opposite symbol. Sorry, it's not always a negative, because if it was a negative, then it would turn into a positive, right? So we put a subtraction symbol above the symbol that was already there, and then you can tell yourself, okay, that's really what's happening. The one that's on top is what's really happening. Okay, so now let's go back to the simple example. After we had the 3 and we subtracted the 3, we would end up with 4 minus 3, which is 1, and then we would carry the 7 down. Recall that. So that's exactly what happens in this situation. The 3x cubes will cancel out. Negative x squared minus 6x squared gives you negative 7x squared, and the rest of that question, everything else that is there, is actually just going to get carried down, right? Like that. So when you carry it down, you end up with negative 7x squared plus x minus 2. And I want you to just think about what would you have done if this was a long division problem, right? And I've got something over here in the corner to explain it to you. So you ask yourself, how many times does now 3 go into 17? And 3 goes into 17 5 times. So what I'm trying to explain to you is basically you run through this algorithm. This is called an algorithm, the division algorithm, and you run through it again. So you ask yourself, okay, what is negative 7x squared divided by x, right? So you take that first term of that divisor and you ask yourself, how many times does it go into negative 7x squared, basically. That's the idea right there, right? So our next step here is to ask ourselves, what's negative 7x squared divided by x? Recall that that's the same x that you had asked yourself earlier about, and it's the same x that you're asking yourself this time about. The only difference is before you were talking about the 3x cubed, which was the beginning of the dividend before, and now it's negative 7x squared, which is the beginning of the dividend now, right? So just kind of keep track of where we're at. Okay, so the answer that you should get to that, by the way, is negative 7x, right? Negative 7x. So you can now go to the quotient and you can put negative 7x right there. And you ask yourself then the question, what is x plus 2? So we're repeating the algorithm. Look at step number 2. We're basically doing again in step number 2, but we're doing it in step number 4 this time. So now we ask ourselves, what's x plus 2 times negative 7x, right? So when you do that, you basically end up with the following situation. X times negative 7x is negative 7x squared. So you end up with negative 7x squared. And then 2 times negative 7x is negative 14x. So you have negative 14x right over here. Again, you make yourself a line like this over here. And remember to switch the signs. So the negative is going to become a positive. This negative is going to become a positive, right? Because you're subtracting what you got from negative 7x squared minus 14x like that. So when you do something like that, this is not a coincidence. This is always going to happen. You'll notice that the negative 7x squared and the positive 7x squared, they actually cross off. It's supposed to be that way. If you just give it some thought as to how that came about, it just has to be working out in the way that we talked about it. So now we have x plus 14x, right? X plus 14x is 15x. And yes, now we carry down that minus 2. And you ask yourself, can I still keep going with this question? So here is the question. Can we take 15x, right? 15x, which is the beginning of the question right here, And can we divide it by x? Would we get a result out of that? And you certainly would. Your result would be 15. So what I am implying here is now you go back up to the top and you put 15 right there. Okay, and we're almost done with this problem. And I hope that now that I've run through the steps two times, that you know what to do in this next time. Is just what you did in step 2 and step 4, you're going to do that in step number 6. And so in step number 6, basically what you're going to do is you're going to multiply the divisor, which is x plus 2, times 15 this time, right? So notice where these things are showing up. I'll just highlight this for you. So 3x squared, and you multiplied it by 3x squared. Where did you get that 3x squared? You got it from the top, right? Bismillah. We're running out of colors here, but negative 7x, where did you get that negative 7x from? Right over here. Where does it show up? You multiply it to x plus 2, right? And then finally, for lack of a better color, I'll just go to this different color, blue, but 15, and then 15, and where does that show up? It shows up over here, right? So just kind of, I highlighted that for you just to kind of help you keep track of where we're going with this. So when you ask yourself, what's x times 15, you should get back an answer that is exactly the same as the one above it. So you end up with 15x with a positive. And then you ask yourself, what's 2 times 15? Well, 2 times 15 is 30. So you end up with positive 30 in this situation. All right, so ask yourself, am I forgetting something? And you certainly are. Remember to switch the signs on everything that's on the bottom right there, right? So now when you switch the signs, you'll notice that the 15x and the 15x cross off. However, the negative 2 and the negative 30 are going to give you negative 32. And so that is like this remainder that you used to have at the bottom, right? Over here, that's like the remainder that you used to have. So how do you write out your result when it comes to polynomials? Well, bismillah, here goes. First thing you do is you take everything that you had in that spot and you bring it forward, all right? So you'll have 3x squared minus 7x plus 15, right? That's everything in your quotient. But then to that, you have to actually put the negative 32, right? So we'll make that a minus 32, and you have to divide it by x plus 2. Now, where exactly did we get x plus 2 from? I don't want to make a giant arrow, but the x plus 2 was the thing that you were using to divide by in the first place. So basically what we're implying is we can't make x plus 2 go evenly into 32, so we're just going to write it that way. And so the final answer to the question, you guys are looking at it right over here, and that's your final answer. Okay, so I did number 58 for you, and in a different lecture, which I will kind of just connect to this lecture, inshallah, you guys will get to hear number 62. But that, again, that was done on a different. That you have 5x to the power of 4 minus x squared plus x minus 2, and it's divided by x squared plus 2, right? Like the actual division symbol is what we're talking about, right? So here's how you write this out. All right, so number 62, here's how you write it out. You begin by writing down x squared plus 2 on the outside. And the logic behind that is, if I had told you, all right, I'm just going to write this and then erase it. If I had told you 9 divided by 3, you would have said that means 3. It goes into 9 like that, right? Long division. So this is the long division of polynomials, right? And so you're going to be putting the x squared plus 2 on the outside, which is also known as the divisor, all right? So this is known as the divisor, all right? And it's going into, all right, it's dividing into entire expression of a polynomial. And so it says 5x to the power of 4. We'll put 5x to the power of 4. And then it says minus x squared. What I'm going to do, without much explanation right now, is I'm going to put minus x squared, but after some space, then it says plus x, and then it says minus 2. Now, let me explain to you why we have to give some space. The reason why we give some space is because when you're writing polynomials, you want to write them in standard format. And in standard format, it means you start from the highest power and you travel to the lowest power. So notice how you had a power of 4, and then you had a power of 2, a power of 1, and then a power of 0, right? X to the power of 0. That would have been on the 2. So what was missing, it was an x cubed term. So what we do is we put a placeholder. We say 0 times x cubed right there. Okay, so let's go ahead and start. It's also known as an algorithm. And an algorithm, basically, you keep repeating the same process. Okay, so it takes a learning curve, and let's go ahead and get started. So the first thing that you do is you say, what is x squared, right? How many times does x squared go into 5x to the power of 4? That's the first question you ask yourself. And I don't want to circle too much on the question itself, so I'm just, highlighting for you. So in your mind, here is the question you ask yourself. What's 5x to the power of 4 divided by x squared? And this work I'll leave here, right? So that's the first thing that you do, and the answer that you should come up with is 5x squared, right? So you go to the question and you write down 5x squared at the top like that, all right? Okay, step number 2 is you have to multiply the x squared times the 5x squared. The x squared, you multiply it by the 5x squared. So I'm going to put that as my second step. I am now multiplying x squared and that 5x squared, and you'll come to the conclusion that, wait, doesn't that give you 5x to the power of 4? And it certainly does. So once you get 5x to the power of 4, you need to go ahead and write that right in the spot. All right? And while I'm here, just to help you kind of wrap your mind around this very difficult idea, if you were dividing 3 into, let's suppose, let me think of a good number. If you were dividing 3 into 47, right? Let's suppose you were dividing 3 into 47. You would have said 3 goes into 4 once, right? And then you would have said 3 times 1 is 3. And then what would you do after that? You would have subtracted the 2, right? You wouldn't add the 2. And you would say that 4 minus 3 is 1. So I'm going to leave that up here so that you understand this next step. What you do after having done that is, where are we? We're at x squared times 5x squared, and we got 5x to the power of 4, right? But after that, this is what's so weird. Because these are polynomials, you need to take the 2 and also multiply it to 5x squared. So what am I saying? You have to take the 2 and also multiply it to 5x squared. And when you do that, you end up with 10x to the power of 2, all right? So when you have 10x to the power of 2 as your answer to that piece, where exactly does that go is a really important question. Because it's 10x to the power of 2, you write it underneath the x to the power of 2, like this, right? So be careful. Don't write it underneath the 0x cubed. That's just a placeholder. Okay, then what you do is you go ahead and you make a line like this. Or you make a line, and you're supposed to subtract the top polynomial from the bottom polynomial, right? And so really what's happening is you're going to be switching the signs on everything that's on the bottom, right? That's often forgotten by students, and I reminded you of why we did that. It's because we used to subtract the 4 and the 3. So you change that positive 5x to the power of 4 to minus 5x to the power of 4, and you change the plus 10x squared to a minus 10x squared, like that, okay? Now, let's go ahead and combine these two. It starts to get a little bit easier. 5x to the power of 4 minus 5x to the power of 4, it's going to give you a 0. That is always going to happen. That process is always going to occur. If it doesn't, that means you did it wrong, okay? Then, negative x squared times negative x squared minus 10x squared. Remember, we switched the sign, so it's minus now. It's not positive. So minus 10x squared is going to give you minus 11x squared, like this. as far as the placeholder is concerned and everything else is concerned, now you bring everything else down. You bring down the 0x cubed, you bring down the x, and you bring down the minus 2. And so if you want to call this as step 3, in a step 3, basically what you do is you subtract. Okay, I'm just going to leave it as subtract, and then you carry down the remainder. All right, and just to help you, if you ever get stuck with this problem, I know it's difficult, just think back to how you used to do it before, right? So 3 goes into 4 once, 3 times 1 is 3, 4 minus 3 is 1, and then you bring down the remainder of 7. So 3 goes into 17 becomes the next question. And so that's exactly what's about to happen here, is once you bring down the plus x and the minus 2, and of course the 0x cubed, then you ask yourself, Bismillah, what is the, what do I need to solve for here now, right? Now, first off, let's clear out some of the clutter. We don't need the zeros, okay? We don't need the 0x cubed because we're past that now. And what I mean by past it is now we've jumped from x to the power 4 to x to the power 2, so we don't need that 0x cubed anymore, all right? It's redundant to have that there. And basically at this stage, you repeat the same exact algorithm. So that's the nice part, is you repeat the same exact algorithm. And what that means is you ask yourself, okay, now, what's x squared goes into negative 11x squared, right? Like how many times does x squared go into negative 11x squared? Just like over here, you would have asked, how many times does 3 go into 17, all right? So here goes, x squared goes into negative 11x squared how many times, right? If you can't think of a good way to do it, let me just put a little reminder for you. What really happening is you're asking yourself, what's negative 11x squared divided by x squared, like that. And what you would end up with saying is, well, that's negative 11. And so therefore, we're going to go to the top again, and we're going to put a negative 11 in that space. All right, then what is the thing that we did in step number 2? Is whatever we had found, we went ahead and we multiplied. Whatever we had found in that first step, then we multiplied it to what was out there as the divisor. So you're going to repeat that step again, right? You're going to repeat that step again, and you're going to say, all right, now it's going to be x squared multiplied by negative 11, and it's going to be x squared multiplied, 2 multiplied by negative 11, like this, right? And so the first one is going to give you negative 11x squared. The next one is going to give you negative 22. So going back to our question, now that we have the negative 11, x squared times negative 11 is going to give you negative 11x squared. So I'm going to go ahead and write it in, negative 11x squared. And if you're thinking, shouldn't you switch the sign? We'll do that in just a moment. And then what is 2 times negative 11? That's negative 22. And because it's negative 22, you're going to put that underneath the 2, right? Be careful. You don't want to put it underneath the x because you can't combine an x and a 22, right? That's why we do it that way. So now, again, what was the last step to the algorithm? The last step to the algorithm was to subtract, right? We have to subtract and then find the remainder. So we're basically repeating that process all over again. All right, so here goes. When you say I'm going to take negative 11x squared and subtract positive 11x squared, that really means, you're going to subtract negative 11x squared, that really means you're adding the 2, right? So once again, you'll notice that that first term is going to cross off and you end up with a 0. This time, I'm not going to bother to write a 0. You understand that those cross off. And then on the end over here, we have negative 2 minus 22, which actually gives you negative 24. And so all that's remaining to bring down is the x. So you end up with x minus 24 like this. All right. Now you're probably saying, are we about to run the same algorithm again? Let me pause here and remind you of something. Once you ask yourself, how many times does 3 go into 17? And you came up with the answer 5. 3 times 5 was 15. Then when you subtracted those two, you'd get 2. At that stage, you would stop. As long as you weren't working with decimals, you would not ask yourself, how many times 3 go into 2? And the reason why you would do that is you'd say because 3 is a number, that divisor is a number that's greater than the remainder, right? And so you wouldn't go any further with that. Well, that's the same exact idea. When you notice that the degree on the divisor is higher than the degree on the thing that you're dividing into, that's where you stop. Okay, so quite a process right there that you're doing. And so you are at the end of the question, and here's how you write down the final answer. Your final answer even looks even weirder. Basically, what you do is you take the 5x squared minus 11, and you begin by writing that. So 5x squared minus 11, like this. Okay, and then you take the divisor, right? You take the you take that remainder, right? This is the remainder. You take the remainder and you write it as the following. You write down plus x minus 24, and finally you put it divided by x squared plus 2. So believe it or not, that's called polynomial division, and it is quite something. All right, it's quite something. You have to learn it. As difficult as it seems, you have to learn it. In the homework, you will be asked to check your answers. All right, how do you check your answers? You're probably wondering, that was hard enough to get to the answer. Now you want us to check our answer, but certainly you need to check your answer to this. So the way that you check your answer in this situation is the following. You basically take the x squared plus 2 and you multiply it to x minus 24, and you take the x squared plus 2 and you multiply it to the 5x squared minus 11. Here's what I mean to say. To check your answer, basically what you need to do is multiply x squared plus 2 and 5x squared minus 11, right? And you need to add that to x minus 24 if you get the same answer as the question itself, right? And the question was 5x to the power of 4, and then minus x squared, and then plus x minus 2. Then and only then you got the correct answer. If you didn't get the correct answer, then that means you went somewhere wrong with your polynomial division. We are going to try number 70. All right, we're going to take a look at number 70 here. And number 70, one problem with it is it's kind of written in a different fashion. Notice that it's not written in standard form. It's written 1 minus x squared plus x to the power of 4. So one of the things that we'll do is we'll write it in a forward fashion. So really what I'm trying to imply here is x to the power of 4 minus x squared plus 1 would make a lot more sense, right? Well, let's go ahead and try number 70. You've gotten 2 examples, so it should be really more of the same as we go through number 70 here. So, Bismillah, first thing that you have to realize is what goes on the outside. What is the divisor is x squared minus x plus 1. And then what goes on the inside is x to the power of 4 minus x to the power of 3 with a 0 on it, plus minus, but let me start with that again. So, because you're probably wondering, wait, why did you get the 0? So as a placeholder, we'll put 0 x cubed like this, right? And then we'll put minus x squared. And once again, as a placeholder, we'll use plus 0x, and then we'll put a plus 1 right there. So there are 2 placeholders here. There's a placeholder with an x cubed on it and a placeholder with an x on it. It's because the original question doesn't have an x cubed or an x term, and you need to write things as far as we're concerned 4, 3, 2, 1, and then no x's. So what we do is we basically leave those placeholders. But then again, you learned that in that previous example as well. All right? So now what we're going to do is we're going to go ahead and start with that first term, right? We're going to take the first term, and I'll write the algorithm for you once again. You're going to take x to the power of 4, and you're going to divide it by x to the power of 2, and what you should say back is the answer is x squared. All right. Then step number 2 is you're going to take everything that you have out front in the divisor. So x squared minus x plus 1, and you're going to multiply it to the x squared that you just got, right? That x squared, you just got it. So let's go ahead and multiply. And so when you multiply that, you basically end up with x to the power of 4. So x to the power of 4, that was expected. And then negative x times x squared gives you negative x cubed. And notice that this is why it was an intelligent idea to put a placeholder right there, because now you've got x squared times x squared, which is x to the power of 4, all good. But then when you say, what's negative x times x squared? That's negative x cubed. And had you not put a placeholder, you've been like, wait, where did I put the negative x cubed? Do you understand now, right? Now, what's 1 times x squared? 1 times x squared is positive x squared, so you put a plus x squared right here. Now, the next step that we take is to switch all the signs. So we switch the positive to a negative, the negative to a positive, the positive to a negative. And then here's what should happen. Those first two terms should cross off, and they do, right? Then you ask yourself, what's 0 plus 1 x cubed? And the answer is, well, that would be x cubed. And then you ask yourself, what's negative x squared minus x squared, right? So be careful with that one, because you really want to cancel things out, but that doesn't really quite cut it for you there. And so what we're really left over with when we're done with that is we have a 0x and a 1 that need to be brought down. So I'm going to bring down the 0x and the 1. And we're going to start with this algorithm all over again. So what's the next step in the algorithm? You ask yourself, what is x cubed divided by x squared, right? So the first term right here, what is that divided by the first term right here, which is x squared? So when we do that, we end up with an answer of x. All right. What do we do next? We take everything that is in the divisor, x squared minus x plus 1. And before I forget, let's make sure that we put this x in the quotient right here. So we got plus x, and now what we're doing is we're taking everything here and we're multiplying it to that x that's right over there, the one that we just got. So that process is highlighted for you in this algorithm in step number 4. So let's go ahead and give that a shot. Now, when we do this, you ask yourself, what's x squared times x? And x squared times x is going to give you x cubed. And there you go. You expected that to happen. Now, what is negative x times x? That's negative x squared. So this is a negative x squared. And finally, what's 1 times x? It's actually x. And I remind you again that the benefit of having put a placeholder here is we actually have a place to put the 1x underneath, because it can't go under the 1, sorry. Now, we repeat that algorithm. So everything here switches signs like that. And then you know and you expect that the x cubes will cancel out, and they do. Then you have negative 2x squared plus x squared, which gives you negative x squared, right? And then you have 0x minus 1x, so that gives you minus 1x. And then you still have a remainder, and that remainder is a plus 1. So you repeat the algorithm a third time, right? You repeat the algorithm a third time. So let's go ahead and start. Step number 5, in a sense. You're going to take the first term out front, which is negative x squared, all right? And you're going to divide it by x squared. So the first term of the divisor. And this time what you end up with is a negative 1. So you put the minus 1 in the top in the quotient, and you ask yourself the question, what is x squared minus x plus 1 times negative 1? So everything that is in the divisor multiplied by what you just got in the quotient, the new thing in the quotient, right? And so what you end up with here, let's go ahead and write that answer in this line. X squared times negative 1 is negative x squared. So you have a negative x squared. And then negative x times negative 1 is positive x, so a positive x. And finally, 1 times negative 1 is a negative 1, like that. All right, now we're going to go ahead and make sure that we switch the sign on everything. So sign switch, and sign switch. And notice how now the negative x squared and the positive x squared, they cross off. The negative 1x and the negative 1x become a negative 2x, and the positive 1 and the positive 1 make a positive 2, like that. Now, if you're wondering, can we continue on with this exercise? Can we take the negative 2x and divide it by the x squared? And the answer to that question is no, right? You don't do that. And so when do you know when to stop? Notice that the degree on the x is a first degree, right? It's a first degree. So first degree. And notice that the degree on the first term in the divisor is a second degree. And because that is a second degree, and the degree of the divisor is more than the degree of the remainder, you're not going to continue to go through this process. Right? So you don't go through that process anymore, and you do choose to stop right there. And so let's go ahead and write out the final answer. Remember, it all starts off with this. That is our biggest result. So you start off with x squared plus x minus 1. And now let's talk about the remainder. The remainder is negative 2x plus 2, and it's divided by the divisor, which is x squared minus x plus 1. So that right there is the final answer. And in that previous question, or in number 62, basically, as I talked about, you can check your answer as well, and basically just kind of going back the other way. And if you ever get lost in going like, wait, how do you exactly check your answer? Let's think of that simpler question that we have referred to twice, I would assume. If you think about how did you check your answer, you would have said, well, let's take 3 and multiply it to 15, right? Let's take 3 and multiply it to 15, and then add it to the remainder, which was 2. So if you added it to the remainder, that's 45 plus 2, and that gives you 47. And because you end up with the same thing that was inside the quotient, the division sign, which is called the dividend, then you know that you did it correctly. So the same logic actually applies over here. Is you take everything that is in the quotient and the divisor. So basically, you take x squared minus x plus 1. So if you wanted to check your answer, which I believe you have to do it for this exercise because you're only doing so many of them. So x squared minus x and then add 1. If you take that and you multiply it to the answer that you got, which is over here, so x squared plus x minus 1, right? And then whatever you get with that, if you add it to your remainder, and your remainder was negative 2x plus 2, what that should take you back to is the question itself. And the question was x to the power of 4 minus x squared, right? So x to the power of 4 minus x squared plus 1. It should equal that. It should equal that. If it doesn't equal that, then clearly there was a mistake in getting this done. Now, one of the reasons why it's kind of a silly idea to check your answer and most people don't bother is because think about how much work it took you to get to that answer and how much easier it is to just retrace your old steps than for you to go through a whole different, huge problem, by the way, and then say, I'm just trying to check my answer. Now what we're going to try is an alternative method. All right, so it's an alternative method, and that is to long division. So notice how long division, it takes a while, it's difficult, you can miss a lot of things here. It's difficult for everybody. Nobody says, oh, that was easy, and they get done with it. So it takes a little bit of time to kind of get used to that process. But the alternative method to long division is called synthetic division. All right, so it's a whole lot easier to do, but there is a catch. With almost anything that is a shortcut, it only works sometimes. So let's get this out of the way. First off, you can only use synthetic division, which I'm about to detail for you exactly what is synthetic division in a moment. You can only use this process of synthetic division so as long as you have a factor, right? So as long as you have a factor that looks like x minus something or x plus something. So in other words, as long as your factor, all right, as long as your factor or your divisor, if you want to call it, is x minus some number, let's call it x minus a, or x plus a, you can go ahead and do what you have to do. But otherwise, you can't do synthetic division. So this is the only situation where synthetic division actually works. If that's not your factor, you have to throw out everything you know about synthetic division, unfortunately, and you do have to do long division. So this is not an end all going like, okay, let's just forget about long division altogether. So for this, I'm going to try a handful of questions as well, right? So let's go ahead and try number 8, right? So number 8 is a relatively simple one. First off, I just want to remind you that this is an alternative to you doing what? To you saying x plus 2 goes into negative 4x cubed plus 2x squared minus x and then add 1, right? So this is an alternative to that method that would have taken us a longer time to do. So what you can do is you could pause the video and you could give it a shot. Number 8, try to see what you'll end up with as an answer. But what we're going to do is, so that we don't have to make this video longer than it already has become, is I'm going to teach you the synthetic way of doing the question. Right, so this is called synthetic division. In synthetic division, basically what you do is you begin by writing down negative 2. All right, so you write down negative 2 like that, and you put a backwards L around it, like this right here. So if you're wondering why does that say negative 2 and not positive 2, well, the conversation about that is really you take the x plus 2 and you really write it as x minus negative 2. And that's the problem with trick methods, you know, like you got to do special kinds of things to make it work. So this is one of those situations where you basically have to take the opposite of that 2, which is a negative 2, and put it in that spot. Now, the next thing that you're going to do is you're going to write down negative 4 positive 2, I apologize, negative 4, positive 2, negative 1, and positive 1. I'm emphasizing that by putting a positive next to it. Now, you're probably wondering, wait, where exactly did you get these numbers from? So let me detail that for you. The first coefficient was negative 4. The next one was a positive 2. The next one is a negative 1, and the last one is a positive 1. So that's where I got these 4 numbers from. So as soon as you pick this up, you'll be like, wow, I wish all of long division could be this way. Now what you do is you basically make a line that looks like this right here. All right, now let's go ahead and start. Step number 1, you bring down the negative 4. So you bring down the negative 4. That's step number 1. If you want, I can detail it for you here. Is bring down the negative 4, just so you can keep track of what we're doing. All right, step number 2, you're going to multiply the negative 2 and the negative 4. So the negative 2 out here, you're going to multiply it to the negative 4 in here. And when you do that, you end up with a positive 8. Now, where does that positive 8 go? I'm going to make an arrow for you. The positive 8 goes right over here. And you're done with the first algorithm, the first iteration of the algorithm. Now you're going to start the process all over again. So the next step is to go ahead and add the 2 and the 8, and you end up with 10. So you've got a 10 that you're working with like this. All right. Once you have that 10, you basically, all you need to do is multiply the -2 and the 10, right? So you're going to go ahead and multiply -2 times 10, which gives you what? It gives you -20. So when you get -20, the -20, bismillah, is going to go right over here. All right, what's the next step? The next step is to take the -1 and add it to the -20. All right, what do you get now? You get -21. So you have a -21. And I'm going to stop enumerating it over here because I think you're getting the idea. Now you're going to multiply the -2 and the -21, and you get +42. So what goes in this spot is a +42. And for one last time, you add the 1 and the 42, and you get a 43. Now be careful. When you get to this end, what you want to do is make a forward L on that final piece. That final piece represents actually the remainder, right? The final piece actually represents the remainder. So now we are ready to write down the answer. The answer looks like this, all right? So if your term started off with an x cubed, your answer is going to start off with an x squared. So watch how I pull these numbers apart. I'm going to take the -4, I'm going to write down -4x squared. Then I'm going to take the 10, I'm going to write down plus 10x. If you're wondering why is it plus, is because that 10 was a positive, right? And then I'm going to take that -21, I'm going to write it as -21. And so what does that leave? It leaves that 43. So the 43 is written like this. You write down 43 divided by the original divisor, which is over here, right? So you divide the 43 by x plus 2. And so if you had done long division, I know the first time you do synthetic division, you're like, what in the world is going on? But like I said, try it the long division way, and the answer that you should get, as long as I did this correctly, is right in front of you over here. So let's try one more question. Now, if we had, more time, we would have done it the long way and the short way, but, obviously the lesson is quite long, so we want to keep it relatively short. So let's take number 12 here. And number 12, same exact idea. First thing that we're going to do is we're going to take the x plus 1, and we're going to realize that that's really x minus -1. So we're going to put a -1 as the number that's out front. Please realize that I've done an x plus 2 and an x plus 1, so it looks like it's always a negative number. It's not always a negative number. For instance, in number 10, if you had used x minus 2, right, the number that would have shown up at the front is actually a 2. So it would have looked like 2 and then all the other numbers that come after that. Because we get that question all the time from students. What number goes in that backwards L? The number that goes there is the opposite of the number that you see here. So you don't find out why that is until you get to pre-calc, but for now, you basically put the opposite of that number in this spot. So it said x plus 1, so you put a -1 right there. Okay, now, let's go ahead and start. The question starts off with x to the power of 5, and so its coefficient is a 1. Now notice that it's missing an x to the power of 4, right? So what is it missing? It's missing a few things, but it's missing an x to the power of 4. Now what did we used to do in long division when that was not accounted for? We used to still put an x to the power of 4, but we would put a coefficient of 0 on it. So that's exactly what I do here, is after x to the power of 5, I put a 0 for x to the power of 4. If it helps you to think about it, think of it this as x5, x to the power of 4, x to the power of 3, x to the power of 2, x to the power of 1, x to the power of 0. Think of it that way, if it helps, right? So we're just putting things in their proper spot. Now, the next coefficient is 5x cubed, so take out the coefficient from that, so you have a positive 5. And then notice that it's missing an x squared term and it's missing an x term. So what do? I go to x squared and put a placeholder there and I put a placeholder for x to the power of 1. In other words, 0 times x to the power 2 is still going to give you 0, right? And finally, this last one right here, that's really the constants column, right? Because x to the power 0 is 1. So this is the constants column, and the constant that you have in this question, you actually have one, it's a minus 10. So I'm going to put a minus 10. So what I've done here is I've put in blue things that are actually present, and then I put in red things that we're just using as placeholders. But you have to write things from the highest power to the lowest power. If you're wondering, why did that not matter in number 8? Well, look at number 8 very carefully. It was x cubed, x squared, x to the power 1, and x to the power of 0. That's why it didn't matter. But now it does, because they're definitely skipping some of the degrees over there. Okay, now we're just going to repeat the algorithm. There's nothing different about it. I just wanted to give you 2 examples as opposed to just one, even though I would say most people can just take one example and be like, yeah, I understand the algorithm, right? So let's go ahead and begin. You initiate this by bringing down the 1. Then you multiply the negative 1 and the 1, and you get negative 1, and that is going to go back into this spot, right? And that's why we put a placeholder there in the first place. Now 0 add negative 1 gives you negative 1, and then negative 1 multiplied by negative 1 gives you positive 1, so what goes back up here is a positive 1. Now 5 plus 1 is 6. 6 times negative 1 is negative 6. 0 plus negative 6 is negative 6. Negative 1 times negative 6 is positive 6. 0 plus 6 is 6. Negative 1 times 6 is negative 6. And so we come to the end of this as well. Negative 10 plus negative 6 is negative 16. Remember to always put a forwards L right over there, because that represents what? It represents the remainder. And so let's go ahead and write in the answer. So realize that we started off with x to the power of 5. So your answer is going to start off with x to the power of 4. So let's go ahead and start. The answer is going to be 1x to the power of 4 minus x to the power of 3 plus 6x squared minus 6x plus 6, and finally minus 16 divided by the original divisor, which was x plus 1 in this scenario. So imagine if you had to do this by long division, it would have been really painful. So synthetic division can really save us quite a bit of time right there. But remember, the caveat is you must have something that looks like x minus a and x plus a. So then and only then will it work. And the other thing to just remind you of is you need to make sure that you always switch the sign before you put it into the synthetic division piece. So if it was a negative number, it's going to show up as a positive right over here. If it was a positive, it's going to show up as a negative right over there. Well, thank you so much for listening, and assalamu alaikum.